Right, this video is on using transformations to sketch exponentials. I'll go through 4 graphs. I think that'd be enough. So the first one is sketch y equals 5 times 3 to the x. We've been doing a little bit of work on transformations, so it's sort of quite timely, I guess. If f of x, let's do this over here, is equal to 3 to the power of x, then just to recap, this is bigger than 1, it's not a minus x, it's exponential growth. So that is y equals 3 to the power of x. Timesing by 5, this is equivalent to having 5 f of x. So it's a stretch scale factor 5 in the y direction from this graph here. So when x is 0, we've got 5 times 3 to the power 0, which is 5 times 1, which is 5. You're expecting this to be 5 if it's a stretch in the y direction. But to find your y-axis intercept, you can always let x equal 0, just to make that clear. And then it's exponential growth. You don't have to draw it like this. It's sort of going through higher up on your y-axis, because the y-axis can be any scale. So to be honest, I would just draw this as pretty much the same as the other one, but just label that 5 instead of 1, so that you get that nice exponential shape. Asymptote here still on the x-axis. I don't know if I need to write that on or not. Asymptote at y equals 0. So that's the first one. Second one, we can look at sketching y equals 4 to the power of x plus 2. So similarly, if we think of f of x as being 4 to the x, that's going to look similar to 3 to the x, so it's exponential growth going through 1. This here now is f of x plus 2. So it's this graph here has been moved up by 2 to get to this graph here. Again, you could let x equal 0 and then y is equal to 4 to the power 0 plus 2, which gives you 3. So if you're a little bit unsure, you can use your y-axis intercept to help you a little bit. Moving this graph here up by 2, you need to pick up the asymptote and move it up by 2. And I would do that first. Put the asymptote in as a dotted line. And then it's going through 3 on the y-axis. It's easier to put that in afterwards actually, but we want it to come through about here. So it's exponential growth going through 3 on the y-axis. This scale doesn't need to be perfect. Get it as good as you can. So your marks are for your asymptote, your shape, and your y-axis intercept. Okay, that's that one. And then we can do sketch y equals 1/3 to the power of x minus 2. I did go over this on my previous video. That's exactly the same if you split that power as having 3 to the power of minus x minus 2. So you could write that as a number 1 over a third, which gives you 3 to the power of minus x. So 3 to the minus x, or a third to the x, is exponential decay. So that one there is coming down through like so. And then it will have been moved down by 2. So similarly, if this is your f of x, then this here becomes f of x minus 2. So transformations are actually really useful in curve sketching. So this time I want to pick up the asymptote and move it down by 2. When x is 0, y is equal to 3 to the power 0 minus 2, which is 1 minus 2, which is minus 1. It's kind of what you're expecting. So it's going to go through minus 1, and it's exponential decay. So it's coming down onto the asymptote. Like so. So same thing, asymptote, shape, y-axis intercept. And then I'll just do one more. So if we look at doing a stretch and a translation. So similarly again, if you've got f of x equals 2 to the power of x, so that is exponential growth going through 1. Then this is like having 4 lots of f of x plus 3. So you've got a stretch by 4 in the y direction, and then plus 3 moves you up by 3. So if you're getting the hang of this quite quickly, you'll see that the asymptote is going to move up to y equals 3, and then the y-axis intercept will be at 7, which is 4 plus 3. But you might want to just break that down a little bit. So when x is 0, y is equal to 4 times 2 to the power 0 plus 3. 2 to the power 0 is 1, 4 plus 3 is 7. This is a stretch, this moves you up by 3. So we don't need to think about what's happening as things approach infinity. We can use transformations instead. So up by 3, passing through 7, and it's exponential growth. A is bigger than 1. So you might find, I find this more useful actually, that if you kind of do the best you can with it and then mark that on afterwards. But don't worry if it's a little bit off on your scale. So same thing, asymptote, y-axis intercept, and exponential shape. So if you go to your lesson folder, there's some questions that I've taken a photograph of on the board, and there's answers as well. So it's sketching some exponential curves and bringing in some transformations as well.